energy and forms. Okay, welcome to the lesson. Today we shall be looking at what? Energy. What is energy? Energy is everywhere. Energy is the sound you hear. Energy is the light you see. Energy is the cool wind that touches you on a cool day. If you kick a ball, you pick up a bag, you press a spring, all these you use what? Energy. What about plants and animals? We all need energy for what? For growth. And also to keep us what? Working. Many forms of what? Energy. We have heat energy, we have chemical energy, we have electromagnetic energy, we have nuclear energy, we have mechanical energy, we have solar energy, we have light energy, and we have hydro energy. Okay, and we also have wind energy. All these are different ways in which energy exists. All these are different ways in which energy exists. Okay, there are more than these, but these are the important ones. All right, let's look at heat energy. Heat energy is the total internal energy of what? Of a body. Okay, the total internal energy of a body is called the heat energy. Heat energy can be produced by what? Friction. Not friction is it not? Close contact produces what? Heat. Rub your two palms together tightly. Rub it very tightly. Now feel the hotness of your palm. That is what they are trying to tell you. Okay. Heat energy also causes changes in temperature and phase of any form of matter. Solid changes to liquid because of heat. True or false? Yes. If you heat your eyes, what happens to it? It changes to water. If you heat water, it changes to what? Gas. So what I'm trying to tell you is that the more heat you add, the more the matter will change its state. Okay. We now look at chemical energy. Chemical energy is required to bond atoms together. What do I mean? Most of the things you see, like the plant around you, they are what we call chemicals. They all have chemicals. These chemicals are joined together. Okay? The thing that hold them together plus the chemical together is what we call chemical energy. Okay? And when bonds are broken, energy is what? Released. Is it not? Yes. You already know that. If we explode a bomb, a grenade, for example, what happens? Energy is released, is it not? In form of heat, sound, and what? And light, is it not? Yes. So you must understand that, okay? Fuel and food are forms of what? Stored chemical energy, is it not? Yes, these are examples of chemical energies. Then let's look at electromagnetic energy. When we talk of electromagnetic energy, we're talking about electricity, mainly electricity, okay? Then sometimes they're connected with magnetic field, but we're talking about mainly what? Electricity. Power lines carry electromagnetic energy into your home in the form of what? Electricity. True or false? True, you already know that. Light is a form of electromagnetic energy. Each color of light represents what? A different amount of electromagnetic energy. You already know that in the electromagnetic spectrum, is it not? Now, electromagnetic energy is also carried by what? X-ray, radio waves, and what? Laser light. You already know these ones. Now, let's look at nuclear energy. When we talk of nuclear energy, we're looking at another kind of energy that is produced by atoms. These atoms are so powerful that they keep producing energy on their own, while some are done by scientists. Okay, that kind of energy produced by such atom or element is called nuclear energy, and we use this nuclear energy in different ways. Okay, we use them in different ways. You must know that we use them in different ways. Nuclear energy is the most concentrated form of what? Energy. See it? Yeah, it can be involved in so many different activities. So can divine energy has the ability to cause a change. Why do we say energy is the ability to cause a change? Because whenever there's energy, there's always change. Let's look at it this way. When plant acquire energy from the sunlight, over time what happens? It changes, it grows. Is it not? The food you eat gives you energy and make you grow. Can you go back to the way you were before? No. That is why I will say energy always causes what? Change. A room is dark, you put on the light, what happens? Everywhere changes from darkness to what? To light. That is change. So whenever there is a change, you know that there is what? Energy present. We also define energy ability to do work, is it not? Yes, whatever can do work is energy. If an object or an organism does work, okay, exert a force over a distance to move an object. The object or organism uses what? Energy. You walk from your home or from school or from the gate down to the classroom. You have used energy. Mechanical energy, okay? When work is done to an object, it acquires energy. The energy is acquired is known as what? Mechanical energy. I've told you before, mechanical energy is when you have potential energy and kinetic energy together. Is it not? Yes. Potential energy and kinetic energy together, it gives you what? Mechanical energy. If you, for example, you can transfer energy to an object that does not have energy, that object that does not have energy will not acquire your energy and begin to move. When that object begins to move, we say that object has mechanical energy. Okay. For example, let me say when you kick a ball, okay, if you kick a ball, you give mechanical energy to the what? To the football, which make it what? Move. When you are playing this pins ball, when you try to hit all the pins, you transfer mechanical energy to the what? To the ball, which is also transferred from the ball to the pins. Sometimes all the pins will fall, other times some will what? Will be left. Let's now look at energy transformation. When we talk of energy transformation, we mean our energy is changed from one form to another. Our energy is what? Converted. In life or in general, energy are continuously what? Changing, which we are going to learn very soon. Okay, all forms of energy can be converted into other forms of energy, is it not? Yes. The sun's energy through solar cells can be converted directly into electricity, is it not? Yes. Green plants get the sun energy and they change it into their what? Chemical energy, is it not? Yes. So you can see there are many forms of what? Energy conversion. In an electric motor, electromagnetic energy is converted to what? Mechanical energy, or you say motion energy. In a battery, chemical energy is converted into electrical energy. The mechanical energy of a water is also converted into what? Electrical energy. Is it not? Yes. Which we also call hydro energy. Is it not? Yes. You can see an example there, okay? In an automobile engine, fuel burn to convert what? Chemical energy into heat energy. The heat energy is then changed into what? Mechanical energy. You can see it there. The car engine, motorcycle engine, all of them, okay? This is the energy conversion that is taking place. So chemical plus heat to give you what? Mechanical. States of what? Energy. Let's look at the main state of energy or types of what? Energy. Okay. The most common energy conversion is the conversion between potential and what? Kinetic energy. All the forms of energy that we've just finished discussing just are close into. It is either potential or what? Kinetic. When we talk of potential, we talk about an energy that is what? Stored. The object have energy to do work, but it's not doing work yet. Okay. When we talk of kinetic energy, we're talking about an energy that is in motion, that is actually moving, not doing work. So those are the two different forms of what? Energy we have. Let's take a more broader look at kinetic. The energy of motion is called kinetic energy. If an object is moving faster, it will have more kinetic energy. If the mass of the object is greater, it will have more kinetic what? Energy. Okay. Kinetic energy depends on both the mass and the velocity. So the more the mass, the more the velocity, the more the kinetic energy. All right. On the other hand, potential energy is stored energy. Okay. We have potential energy stored chemically in the nucleus of atoms and in what? Foods. Is it not? Example of other things that potential energy, you can say stretching a rubber band. When you stretch a rubber band, it has energy. What energy is that? Potential energy, because once you release it, it will move. True or false? True. winding a watch, pulling back on bow's arrow, okay, and then lifting brick high in the what air. All these are examples of what potential energy. Okay, let's look at another form of something called gravitational potential energy. Gravitational potential energy has to do with a potential energy that is related to what? Gravity. So an apple that is hanged on a tree will have this kind of what? Energy. Is it not? An apple that is hanged on a tree will have this kind of energy. Then let's look at energy that is stored due to being stretched on a rubber band is called elastic potential energy. So you stretch a rubber band, that one is called an elastic potential energy. Energy conservation. When we talk of energy conservation, we're talking about the movement of energy around the universe. Okay, there's a law that governs this energy conservation, and it is called the law of conservation of energy. It says that energy can neither be created nor destroyed, but it can be changed or transferred from one form to another. Do you get it now? So no energy in this life is destroyed. As I'm talking to you now, I'm using chemical energy, which is transferred into what? Sound energy. This sound travels in waves to all different directions, and then it won't fade away. You see it now? No energy is destroyed. It is always what? Converted from one form to what? Another. That is what you should know about the law of conservation of energy. Energy law was brought by scientists called Albert Einstein. Okay? Albert Einstein is one of the greatest scientists that have ever lived. Okay? When he was young, his teacher said that he is not going to be anybody useful in life, but he improved himself and became one of the greatest scientists that has lived. He was the one that was able to tell us that energy actually cannot be destroyed. That if we destroy energy, it will give us mass, and if we destroy mass, it will give us energy. That means energy cannot be destroyed, can only be transferred or changed from one form to another. I want you to watch this video, learn more about energy, potential energy, kinetic energy, and then learn how this energy are transferred. Okay?
Energy is the ability to do work. We experience different forms of energy everywhere all the time. Computers, cars, traffic lights, space shuttles, and headphones are a few of many things that use energy. People, animals, and plants also use a lot of energy to survive. Does that mean we can use up all the energy in the world? Can we create more energy? Well, no. Energy cannot be created or destroyed. It can only be changed from one form to another. The change from one form of energy to another is called energy transformation. Here are some examples of simple energy transformations. A stove transforms electrical energy into heat energy to cook food. A flashlight transforms chemical energy from its battery into light energy. A solar panel transforms light energy from the sun into electrical energy. A microphone transforms sound energy into electrical energy. As you can see, energy is constantly changing forms, but it is not being created or destroyed. Let's look at some examples of multiple energy transformations. A television transforms electrical energy into light and sound energy. A car transforms chemical energy from the fuel into mechanical, kinetic, electrical, light, heat, and sound energy. A robot transforms chemical energy from its battery into kinetic, sound, and light energy. A firecracker transforms chemical energy into kinetic, light, heat, and sound energy. When you rub your hands together, you transform chemical energy from the food you eat into mechanical and kinetic energy in your muscles. Then, that energy is transformed into heat energy. All these examples show that energy is not created or destroyed. It only changes from one form to another.
Welcome back from that video. I believe that with this lesson, you now know what energy is, you know what mechanical energy is, you know heat energy, you know chemical energy, you know electric energy, you know nuclear energy, and then you also know kinetic and potential energy, and then you know what gravitational potential energy is, which has to do with a stored energy that is affected by what? Gravity, because of the height, is it not? Like an mango on a tree. And then you know what elastic potential energy is, which of course is stored energy in stretch rubber band, which of course is stored energy in stretch rubber band. And then you know what energy conversion, energy transformation is, okay? And then you know the law of conservation of energy. That now brings us to the end of the lesson. I want you to do your assignment and stay safe.